Good morning, everyone. Assuming that it's morning to everyone, of course. Alright. Let's continue with organic chemistry. Particular today, we would be more focusing on physical properties. Alright. You might download the notes. I've already uploaded on the website. You can download them and read through before you go to the videos, or you can start with the videos and get more clarity on the notes. All right, let's start with the first bullet on the physical properties. What they are saying here, they are saying if the intermolecular forces are so strong, then the boiling point should increase as well. All right, that means to break to boil that molecule, or to break the intermolecular forces on that molecule, would need more energy. All right, it's more like boiling water. Boiling water is opposed to boiling alcohol. When you're boiling alcohol, maybe you don't need much, it's not even maybe, you don't need much energy or much heat to make sure that you get your alcohol on fire. But if you are boiling water, you have to, need as much energy as you can, meaning you need as much heat as possible. That's what we are saying here. Okay, so that means if they are so strong on the molecule forces in the molecule, then the boiling point will be so higher. We'll need more energy to boil that molecule. Okay. For vapor pressure tends to decrease as intermolecular forces increases. All right. Um, I would give you an example. An example would be when someone has been injured and we want to decrease the temperature on their wound. Right. What they normally do in hospital, they take alcohol and place to where the that person has been injured, okay, to try and decrease their temperature. But you wouldn't do that by putting water on their wound. The only possible way is to get alcohol. Alcohol is because it has a weak intermolecular forces, so it has high boiling point. Higher vapor pressure. Okay. Second one is melting point. Melting point is more of the same as boiling point, as in the molecule forces increases or increase, boiling point also increase. Alright. Here, okay, what we are saying here in your exam, don't mention Van der Waals forces because they stand for all forces. They are not distinguishing factor. Okay, that is in terms of caps are the new cap syllabus. Okay. Here we are saying a molecule that has only positive or negative charges. It's not and, it's all, right? You have to note it on its end. That molecule is called to be London's forces, e.g. hydrogen molecule. Hydrogen would raise positive sign on its end, on both of it end. Even oxygen is gonna be negative, positive, positive. positive, because the carbon will be surrounded by oxygen, and the oxygen they have positive end, all right, and so on and so on. Okay, maybe I will illustrate those in a short while. Okay, these are the weakest forces, meaning the boiling point on those is all the weakest. Okay. The second one to that one, a molecule that has both positive and a negative charges on either end, we call that a dipole forces or dipole forces. Okay, so a stronger than London forces. That example would be chloride. Chloride on hydrochloride. On chloride, we know that it has a negative end, and oxygen hydrogen has a positive end, meaning we have on that molecule both a negative end and a positive, hence it's much stronger than London forces. Same here, around carbon there will be positive end because of hydrogen, but we also have bromide. Bromide would raise a negative end, so the entire molecule would become dipole. All right. Um. All right. So that's the second force that we need to mention. Okay. And the third force would be another dipole forces. All right. But that one has a special bond. That bond is called hydrogen bond. Example of that would be whenever there is an element where there's a hydrogen is bonded with either nitrogen or oxygen or fluorine, because of the fact that these elements have highest electronegativity, thus they have a strong bond which is called hydrogen bond. Meaning for hydrogen bond to exist, there must be hydrogen, of course. Over and above having hydrogen on that compound, there must be these three elements. It's either nitrogen, oxygen, or fluorine. Okay, that's where you have a hydrogen bond. Okay, be careful of those, because if you have a molecule that you are being comparing but it's having these three or one of these, then you have to mention hydrogen bond there, because of course it will have a high hydrogen, it will have high boiling point, and the reason will be it also have a hydrogen bond that increases the intermolecule forces. Okay, let's come here. What is happening? Okay, these are the factors that increases intermolecule forces. Okay, let's look at those. We focus on the chain here. Chain is more, it could be the same as a molecular mass at some point, but at some point you might have what we call structural isomers. In that case, molecular mass is the same, but the chain length is not the same. The longer the chain, the higher the intermolecular forces. Okay, that's what we are saying here. If let's say you are having a compound that is consist of 6 carbon, that is hexane by its nature, but you have hexane and you also have ethyl butane. That ethyl butane, it simply means that we have a branch there, and the branch has 2 carbon, and on the longest chain we have 4 carbon, hence we have butane, right? So that means, in as much as they have a same molecular mass, but because of the fact that hexane has the longest chain, then hexane will have a high would have stronger intermolecular forces, thus high boiling point than ethyl butane. Okay, that's what it is. Yeah, but we'll see from previous questions. Okay, I'll illustrate that. Types of intermolecular forces. You as I said. Okay, another thing would be a type of intermolecular forces. If you are comparing, for instance, um, hydrochloride with, for instance, a hydrofluoride. Of course, hydrofluoride has to have a high intermolecular forces because it has a hydrogen bond. Okay, so it could be because of intermolecular forces that are within that molecule. Okay. Secondly, thirdly would be double bond or triple bond. Okay. If we are comparing butane and butane, a butane has no double bond, but the butane has one. That means the one with the double bond will have a strongest intermolecular forces. Same with the one with a triple bond as compared with the one without. Okay, given that everything else is the same, because if not everything else is the same, in as much as one can have a double bond, but if the other has an advantage of hydrogen bond, that will still, have a high intermolecular forces because of that extra feature over and above not having double bond. Okay, so we'll not focus on those. Okay, and it is important in the questions or for exam technique to mention all of this as so much as they are applicable. Okay, I already said this on the design of the structure being isomers, where you have the same molecule but it has different structures. Okay, nature of the structure. Okay, if the structure is asymmetrical compared to a structure that is symmetrical, then that one, the one with asymmetrical, it would be, the example will be this one. If you look at this one, if you compare methane and this compound, this one, methane has around carbon only hydrogens, so it's symmetrical. But this compound has hydrogens and bromine, so it's not symmetrical, it's asymmetrical. Therefore, this one should have high uh, intermolecular forces, thus a high boiling point. Okay. So I think that's what you have to pay attention to. Okay. Some molecule might have all the types of forces, e.g., alcohol has hydrogen bond and is also a dipole. It has also dipole forces. Same here, and this one also have a double bond. Okay, you need to mention all those things when comparing. Okay, let me quickly come to here. Here you might be given these two, and they both has hydrogen bond, as you can see. They both have hydrogen bond, but the difference now um would be let me quickly turn that. Okay, just a minute. Okay, but the difference would be the fact that nitrogen has a highest electronegativity and size. You need to also compare size. In as much as they both has hydrogen bond, but they won't have the same intermolecular forces because they don't have same mass and they don't have the same electronegativity. Okay, therefore they will have to differ. You need to pay attention to those. You have to mention those in your answers. Okay. Let's come to reaction, which are a bit much easier. I think we would finish them in no time. Okay. Additions. Okay. We are on reaction. Start with additions. For a reaction to be an addition, it means that there must be a double bond on the reactant. Okay. If there's no double bond on the reactant, then there's no addition. You are adding to what? Because there must be a lacking before you add something. If something is already saturated or enough, then what are you adding to? That's the question. Hence, we can't have an addition reaction if there's no double bond. Okay, double bond only exists in alkene in most of the cases, as exist in alkene. So if you have alkene on the reactant, therefore whatever you are doing, it's merely an addition. If you have alkene on the reactant, whatever you are doing, it's merely an addition. Okay, that's how we observe addition reaction. Okay, you might read through this, but what is important is the fact that in reactant you must have alkene for you to have addition reaction. Elimination should be the opposite of this, because if you look on the right hand side, um you started off having, I would say maybe this would be alcohol or something. You started having this, but your result, uh, uh, uh your result or your product have a double bond, meaning that you have eliminated something here. You have eliminated water from this compound, hence it's having a double bond. So elimination should be just an opposite of this, okay, or a reverse reaction. Let's see what they are saying. Alkene must be a product. Here it's a reverse reaction, and alkene is a product. Okay, it's more of a reverse reaction, as I said. Okay, reaction condition. We also need to take into consideration the conditions, because you might be given conditions sometimes, and if the conditions are for elimination, you can say from there, but okay, this should be an elimination, because you might not be given all the facts. If it's a strong heat and there's also a strong bases like your sodium hydroxide or potassium hydroxide, then that is a hint that it's an elimination reaction, because those are the consideration. There's a strong heat and there's also strong base like potassium hydroxide or sodium hydroxide, then that must be elimination. Okay, for substitution, there's there's no alkene everywhere. There must be no alkene everywhere, because you are substituting on something that is already enough. It's more like those who like football. Um, you are substituting from the starting 11. I mean, the players are already 11, so you can't say I'm adding. you are substituting someone because there must be always 11, okay? Hence, there must be no W bond on that thing, on that reaction, on that equation, okay? So, yeah. And the heat merely must be just the mild or just a warm heat, not necessarily too much heat to make a substitution, okay? So yeah, that would be it. That would be it. Or that's dilute as opposed to strong a base, just a dilute base that you have to need. Okay.